Hi everyone, in this video I'm going to talk about how to determine the correlation coefficient using StatCrunch, which we will see is much easier than doing it by hand. The formula for it can look a little daunting. We're also going to talk a little bit about regression, how to use this to determine a best fit equation and a best fit graph, and that's all nice and easy here within StatCrunch. Okay, but first things first, figuring out how to find the correlation coefficient. And I guess before I even say that, make sure if you are staring at your StatCrunch screen right here, kind of following along, or you do it a little bit later on, make sure that you do select one of these data sets on the left hand side. I'm using the male health exam results. You could be using any of the data sets here. The process is going to be the same, but that's the one that I'm using. Okay, what we're going to do, it's going to be similar to say previous weeks when maybe we had to just determine the mean, median, standard deviation, something like that. You went into stat, okay, and when you clicked on stat, you went into summary stats, right? When you were doing the stuff, say for standard deviation or mean, you went into columns, and then you were able to pull up all that information. What we're going to do now, and maybe you guessed it after you already kind of see it there on the screen, since we're looking for the correlation coefficient, is you will go down to, shockingly, correlation, okay? Just one more time to show that. If you click on stat, summary stats, down to correlation, click on that. Okay, and the thing with the correlation, okay, the correlation coefficient is it's showing how strongly two things are correlated, and to determine that you need to actually have two things. You can't just have one kind of piece of data that you're looking at here. You need to be comparing this to that in a sense, and without that you wouldn't be able to find the correlation. And so what we need to make sure we do here is to select two columns. You can't just find the correlation coefficient of one thing. That wouldn't make any sense. So we need to find two things that we're finding that coefficient. Okay, so what I'm going to do is I'm going to select and say, well, maybe there is a correlation between age and WT, which is weight, okay, that maybe as people get older, their weight goes up. Or so as their age goes up, their weight goes up. Or maybe as their age goes up, their weight goes down. Something along those lines. There's some kind of relationship there. And make sure you select both of those. Every computer can be a little different depending on if you're using a Mac or Windows or whatever it might be. Sometimes it's just the command button you need to hit to select two different menu options there. Could be a little different to your computer. Maybe it's shift or something else, okay? But make sure you select both of those. You see both of them appear over here on this side, and then you'll hit next. Don't worry about this right now. There's a lot of little extra features in StatCrunch. It's a pretty powerful program, and so not all of it will be stuff we'll be using. So for right now, just kind of ignore that. Then we hit calculate, and it's nice and simple, straightforward, right there in front of us. The correlation between age and weight is 0.2854, and again, you might need to just kind of truncate that a little bit if it asks you to say just to the first 2 decimal places, 3 decimal places, maybe inside my stats lab or something. You may not want all of those digits for the decimal there. Okay, so that's straightforward. Like I said, the correlation coefficient, go in, enter that information, and you'll get your answer. And now the next thing is this concept we're talking about regression, this relationship between two variables, kind of like the correlation coefficient there, but maybe then being able to graph that relationship, some kind of best fit for that. Okay, and let's see if I can pull this up real quick here, and if we had, let's see if this will, for whatever reason that does not want to work. Oh, now it's working. All right, see if it's just being really slow here. If we had a normal graph, if you had stuff kind of on the bottom of the graph, okay, let's say that's our input, and then over here you have your output. Okay, it's a very rudimentary looking graph, and if we graph things, and maybe this again was at the bottom here, our x values. Okay, if we kind of think back to a previous algebra course, the stuff maybe was covered in week 1, you have down at the bottom there your x values, your input. Over here are like your y values or your output. Okay, and we could maybe graph different points that as, okay, let's think of this again, maybe it's the age and the weight example, that as somebody's a younger age, their weight's here, then as they get a little older, someone else is there, someone else's weight here, and there might be some kind of pattern to it. There may or may not be for sure a pattern, but let's just say in this case as these people are getting, as we're comparing people that are a little older, their weight seems to be getting a little higher up there, okay? And we might then be able to figure out some kind of line that's kind of a best fit. It's not going to go through everything perfectly, but it shows the trend. A lot of times we'll call this a trend line, okay? Because it's showing a general trend of what's happening with this relationship between the age and the weight, okay? And then what would be nice is if we can actually figure out a graph, okay? This right here, if we can get a graph, or if we're able to also get a formula, an equation that will explain this for us, this relationship. And that again kind of goes back to our algebra class, if we remember. If you had something like y equals 2x plus 3, okay, that's a linear equation that kind of explains the relationship between the x and the y. And if we were able to maybe get a relationship, get an equation for this line right here, okay, then what we might be able to do is that once we have that equation, we could even predict future values, is that you could plug in, if someone was 60 years old, you plug that into the equation, it tells you their weight would be this, or they're 70 years old, their weight would be this, and you have something, again, it's an estimate, but based off of the data, you're able to kind of predict things. And this is really useful for business applications because maybe you're graphing revenue and you want to predict in a future year what your revenue is actually going to be at. Okay, so let's go back to the StatCrunch screen there, if it'll work for me here. And perfect. And what we're going to do to determine this to do regression here, to determine a best fit graph, best fit line, and also to get the equation out of it, is we're going to go down to something, surprisingly, regression. Okay, it's nice when this stuff is labeled properly. So again, go into Stat, go down to regression, and you're going to go over to simple linear. As I just drew that graph there, it was kind of a line. That's all we're dealing with right now. You're not going to do anything in this class with polynomial or logistic. Right now we're just keeping it straightforward as just simple linear functions. Okay, so don't worry about the other stuff. So we click on that, and this is kind of similar to when we're doing the correlation coefficient. We need to be comparing two different things, right? Just like I showed that graph there, you need to have something in the x, you need to have something in the y. So for the x, I am going to select age, right? Because that was the thing that was changing along the bottom of the graph. And then on the y, the thing that was going up or down, that is the weight. Okay, so we select our x variable and our y variable, and if we kind of think back to that very ugly graph that I drew a second ago, kind of how that would actually fit on the graph itself. We have those selected, hit next. Again, don't worry about this stuff right now, it's beyond the scope of this chapter. Same thing with this as well. Let's not worry about that at this moment. One thing that I want you to click on is this plot the fitted line, because this is going to then show us a graph, which is going to really kind of tie things together. Okay, so that's the one thing there that I want you to select. Okay, hit next again. Don't worry about this right here, just leave it as is. Hit calculate, and here we go. This also will determine the correlation coefficient for you, so if you don't want to remember anything about what I talked about at the start, you can just forget about that. You could even use this regression area to figure out the correlation coefficient, because it'll be right there. This right here, this weight, okay, equals 153 plus, or 0.4 plus 0.539, etc. times age. This is really what I was talking about a second ago when I gave that equation that was like y equals 2x plus 3. In this case, like the y, the output is the weight, the x is right here is the age, and these are kind of like our numbers. They're a lot messier looking numbers than 2 and 3, but they are numbers nonetheless. And this is a kind of an estimation. It's giving a general idea of what's happening with the data, and you would then be able to potentially pick an age, plug it in right here, multiply it by 0.53, add 153 to it, and you'd get an output. You could kind of predict what the weight might be at that age. Again, not going to be perfect, but it'll give you a general idea. Now, if you want to see the graph, what you're going to do is you're going to go down here to the bottom and hit next. Sometimes we forget this button's even there. Hit next, and we can see this is plotting all the data, and that there is kind of a trend, right? I mean, it's not perfect. There's some individuals who are in their 50s who are a lower weight. There's some, again here, very low weight there, some that are younger that are a little higher weights, but in general, as kind of the age increases, it's kind of gradually increasing, which we saw with that correlation coefficient. There was 0.28, there was some positive correlation, but it wasn't like a perfectly correlated relationship. Okay, and I think this is a nice visual to kind of sum everything up. And so once again, I'll just kind of show things really quickly here. If you want to determine the correlation coefficient by using the regression function, and also to get that best fit line and the equation, click on Stat, go to regression, simple linear, okay, and here you will select your variables. Let's say it's age again and weight. Go forward. Don't worry about that right now. Don't worry about that. We want the plotted line because we want to see the graph. Don't worry about that. Calculate it, and it brings this up, and the next screen is the graph itself. All right, hopefully you found that useful. And as always, let me know if you have any questions. Thanks.